Okay, so this is definitely the fall 2014 review exam version, practice exam 4. Okay, so the reason I say this is fill in the blanks is pretty common. This is very similar to last fall's fill in the blanks, but it's different because we did different puzzles. Okay, if you randomly reassemble a pocket cube, there is a 1 in 12 chance that you'll reassemble it in a solvable position. Okay, I'm not going to ask you why, but, oh sorry, not pocket cube, regular cube is 12. Okay, so I want you to memorize these guys or put them on your crib sheet, but I'll tell you why now. Okay, so the reason why it's 1 in 3 is because the last corner must be rotated correctly. All right, they have to be kind of in sync together. And so you know from your doing the solution that there's no routine that just rotates one corner. You have to either rotate 3 corners together in unison, the same direction, or you can rotate them two corners, but they have to be in opposite directions. Okay, which is, you know, those two conditions I gave you are really the same condition. They just seem like two conditions, but there's really only, there's only so much you can do. The point is the twists on the corners sum up to 0 mod 3. This is the symbol meaning add up. Okay. Next question. For the pyraminx, there's only a 1 in 4 chance. And there's 2 attributes here. There's a 50% chance that you're going to get the even or oddness correct. So the location of all the edges has to always be an even permutation. And the other thing is only an even number of flipped edges are allowed. If these 2 things are satisfied, then you have a solvable position. But there's only a 50-50 chance for each of those 2 things, so combined there's only 1 chance in 4 of kind of guessing that right. Okay, for the 3 cube, we have, actually it's 3 times 4 is 12, because we have the same situation. We have the situation where we have a 1 in 3 chance of getting the corner situation correct. We also have an issue with even oddness, and you also have an issue with flippedness. So you essentially combine these 3 conditions, but it's slightly different. See, on the pyraminx, every position has to be even. Okay, you can't just sometimes be even and sometimes be odd. But and the Rubik's Cube, it's slightly different because even though this condition is identical, you have to have 50% of the edges have to be flipped, and 0 is an even number. But the even oddness is slightly different because for the Rubik's Cube, the edges could be in an even or an odd permutation, but the same with the corners. So both the corners and the edges have the opportunity to be even or odd, but they have to be even or odd at the same time, or else you'll never get them both solved at the same time. Okay? So it's slightly different, but at its heart, it's really the same condition. All right? So that's how you get 112. But I don't require any of this information on your exam. I'm telling you this because I'm hoping that some of you will understand what I'm saying, and it will be cool. Okay, the most scrambled a pocket cube can be is 14 moves by the quarter turn metric or 11 moves by the face turn metric. What that means is if you take a face and rotate it 180 degrees, by the quarter turn metric, that's 2 moves. And by the face turn metric, that's considered 1 move. All right, so it depends which way you're counting your moves. So the most it can get scrambled by the quarter turn metric is 14. Quarter turn metric is oh, I think this is wrong. I think this is quarter turn. I think I'm lying to you. Whoops. I'll go look that up. Sorry. The most scrambled the 3 cube can be is 20 moves, and this is the number of moves required for the famous pattern called super flip, which flips all edges of the cube. I'm going to say, I don't know. I have to look that bit up. But anyway, it is 20 moves and it is super flip, but I just don't remember which metric of moves is being used. Okay, for the 2 cube, how many distinct moves are there? Really just 3. Because unlike the full cube, Here in this cube, right equals left, front equals back, and up equals down in reality. But the point is, you have to basically pick one corner to be stable. And this say, if I want to be able to turn the right face, then I can't turn the left face. And if I want to turn the front, I can't turn the back. And if I want to turn up, I can't turn down. So in this case, this corner is stable, and then we just turn everything around that corner. Okay? So this is the explanation. Right equals left, front equals back, up equals down, and that will be enough to explain your answer.